Hello, and welcome back, everybody, once again to the podcast, episode 48 now. Being said, this is a podcast, so again, the only thing on screen is going to be a shifting visual backdrop. If anybody wants to support the podcast, you can do so through either the PayPal or Patreon links down in the description below and in the top pinned comment. The amount is irrelevant. Anything is tremendously helpful in allowing me to continue to exist in this world. That being said, this was a fun one to see. As I put in the community post area, we have the renewed joke that never dies. Nuclear fusion. 2020 has already been an interesting year, with a lot of people saying history repeats itself in regards to a lot of things that are happening, but a lot of that's political, and that's not what we do here. And history is repeating itself in another way. An old quote has resurfaced again. Nuclear fusion power, commercial nuclear fusion power plants, they're just 30 years away. For anyone who's not aware of the history, basically nuclear fusion power has been just 30 years away for the last 60 years. And now it's just 30 years away again. As the ITER reactor over in Europe, a massive blunder of money and enormously wasted time, is finally back on schedule-ish, sort of. It's a new type of fusion reactor that they're going to test out once it's finished. It was started in 2009, I believe, and it was supposed to be finished in 2019, then it got pushed back to 2022, 2023, 2025, 2026, but now they've actually brought it back 1 year to 2025. So now it's only going to be 6 years behind schedule, and will only have cost a grand total of 20 billion euros, most of which was invested closer towards the beginning. So that was the old euro, the old euro that was worth about $1.30 or $1.40. So equivalent in US dollars between 26 and 28 billion, so we'll call it an even 27. So now it should theoretically, if they're truly on time, be completed in 2025, and then they will start testing it out to check to make sure it's operational, and then they're actually going to start running it and conducting actual tests in 2029 or something, I think. Maybe they brought that back 1 year closer to 2028, and they're going to run tests for a few decades, and they believe that the data they gather from this should be enough to apparently allow for potential nuclear fusion power plants by the second half of the century, which, let's see, when does that start? 2050? It's, 2020 right now? 30 years away, anybody? Man, where have we heard that before? So, nuclear fusion has been just 30 years away for the last 60 years, and in 2050, we'll probably be saying it's just 30 years away again. Except not all of us, because a number of us are probably going to die in the chaos that's going to be gripping the world by that point. But our bleak future aside, yes, they've brought it back 1 year sooner to the original schedule, as opposed to pushing it out yet another year again. So we'll see what this whole thing yields. But if these things, cost 27 billion apiece and take 16 years to construct, plus an additional 4 or so years to test out, I have this sinking feeling, just this tiny trickling of a feeling, that this isn't really going anywhere. And I know that'll get me dislikes inevitably, but fusion's been ridiculously played over and over and over again as, our unobtainium, as the silver bullet, as the grand miracle that's going to save us all and usher in our perfect Star Trek utopia or something. But it ain't. That's not how reality works. Now, nuclear fission already can provide us with a gargantuan amount of power by itself, and we actually have basically an infinite uranium supply due to the diluted concentration of uranium in the seawater of the world's oceans that's naturally there. And there actually is a way that was developed to chemically extract it. And it basically involves these long tether things, or like tentacle-esque things. They kind of look like those big, algae under ocean tree things or vines that wave around. And basically you could stick like a cluster of them underwater in an area where there's a lot of motion, where there's either a lot of tidal movement or there's like an ocean current constantly running over the area. And within a number of weeks, they would basically have grabbed up as much as they could. And so you could just set particular cluster sizes that would absorb up enough uranium out of the seawater to then be processed into enough fuel for a regular nuclear reactor. And it would be a bit expensive. I think they said around $270 per pound is the cost that would be needed to make it economically viable. But that wouldn't really affect the cost of the nuclear electricity itself, because the price of the uranium needed for the reactor isn't really even a factor. It's not a silver bullet or a miracle that would save us and create a utopia by any means. It's just one of numerous options that, is actually real. Geothermal is also out there too, and you can actually do that basically anywhere as long as you're willing to pay to drill deep enough for it. It's not confined to tectonic plate boundaries. It's not confined to volcanoes. There are irregular hotspots literally everywhere. And even aside from that, the temperature gradient is enough that in non-active areas, in non-hotspots, you could still have hot enough surrounding rock to run geothermal as long as you were willing to drill 4 to 6 miles down. And we can actually do that. It's not even all that difficult. Ask the oil and gas industry. Over the last 150 years, we have gotten really, really good at drilling deep holes. And geothermal, unlike solar and wind, doesn't require a absurd amount of rare precious metals and rare earth metals. Or get this, one of the easiest things of all, we could just attach carbon capture units to our coal plants. I mean, depending on the ratio of the carbon you want to capture out of the emissions, the mechanisms would consume anywhere from 1 to, I believe, 15% of the power plant's power output. But, they're already there, and coal works just fine, and there's a lot of it. A lot. 22 trillion tons or so. But finally, leaving that behind, we have a few energy and resource little bits here to throw in. Development is going ahead with the big offshore field offshore of Senegal. It is on track to begin producing oil in 2023. There are several other fields, but the first one is going to start in 2023, and they believe they will be able to bring it up to 100,000 barrels a day to start. Gold prices broke their record, jumping up over $1,900 per ounce. As of the last I looked before recording this, they had actually gone all the way up to $1,957 per ounce. And some of the rare earth prices moved as well. Dysprosium, one of the magnetic rare earths needed for electric motors of all sizes and for wind turbines, and for computer hard drives, dysprosium went up from $349 up to $351 per kilogram. Neodymium, one of the magnetic rare earths also needed for electric motors of all sizes and for wind turbines, went up from $57 up to $58 per kilogram. Terbium, also needed in electric motors of all sizes and in wind turbines and in solid-state memory devices, went up from $758 up to $764 per kilogram. And holmium, needed in lasers of all kinds, whether cutting lasers, research lasers, disk reading lasers, motion sensing lasers, whatever have you, went up a little bit from just under $61 up to just under $62 per kilogram. And silver, we have a funny story about silver. So, You guys probably already know, I say it a lot, global silver production peaked back in 2015, and global output from silver mines has been on the decline since then, while global silver demand, silver consumption is only increasing, especially from the production of solar panels. That's one of its biggest areas now. Well, now we might have to throw in a new source of consumption because the EV research department, electric vehicles, have a potential battery breakthrough that could increase storage efficiency in electric vehicle batteries by adding in silver, which is obviously going to increase silver demand as global silver production continues dropping on its terminal decline, which is then inevitably, once that starts happening, going to exacerbate the silver supply deficit that already exists. And even all else aside, I already had expected silver prices during this decade to likely get up towards or over the $70 per ounce range, potentially higher than that, but I'll have to see what factors develop. And that is it. So thank you everybody for sticking around and listening. Like if you enjoyed, subscribe if you haven't already. If you can and you want to, donate through PayPal or Patreon. Keep everything going, keep me alive. And regardless of what happens anyways, may God bless you all, and I will see you all around next time.